So today we are going to discuss about the process. So before we start the actual process, so first let us study what are the type of process which we have in Unix. Now, for an example, we are having two process, something called as daemon process and the general services. So what is the daemon process is here? Now, when a process is running without the user control, okay, that is directly attaching to a system, okay, directly attaching to a system, that process is called as the daemon process. So where those process will be ending with the word D. So those are considered as the those are considered as the daemon process. Now, okay, here you could be able to see. I can have the same points for the process also here. Schedulers. Okay, here we go. Okay, so there is a process called the daemons. So which stands for the disk and the execution monitor. So which is the system process where the user will not be having the control. Now, say for an example, if we can able to find many process. Or if you go to /var/log. ls-lt. Okay. See here in this directory, can you able to find some of the process which is ending with the D? Modebrobe.d, profile.d, bash completion.d, request-key.d, setup tool.d. So these are the process which is called as the daemon process where we don't have a where we will be not having the control. So whatever this command, like even when we are executing an ls command, when it is throwing the output, so even the execution of this command is called as a process. Now, for an example, I'm just using this ps command. Okay, this ps command will give the details of the process which is running in this terminal. Okay, now here we have the 4 columns, that is PID. So each process will be accommodated with an ID called process ID, which will be the total length of 5. Okay, so now for the currently an a bash shell is running which is having the PID as 3139. Okay, and the TTY, okay, on which terminal it's running. Now say for an example, even we have used this TTY yesterday in using a cron tab. You can able to see the TTY number as /j/PTS 0. Okay, and the time is how long it is running. Okay, see the time when we execute this ps command, so every time it will be generating as a new. Every time it will be generating as a new, and the command, okay, and the process name, which is the ps. Now if you use ps-f, okay, with the option means, then it will be giving more details. Now here you can able to see uid. Okay, so under which user this is running, under which user this process is running, the username, under which PID, under which process ID, okay, PPID 3137. Okay, so what is this 3137 here? Now here we should understand there will be many process, and there will be many process running in. Okay, see here. Now say for an example, I have a process, okay, I have a process which is running with the ID of 3000, okay, and another process which is running with of 2888 something, okay, and 171563, and I have another process called 2508, okay, and something 870 and the 1, okay. Now I can write like this. Okay. Okay. See here you could able to see a correlation. Here I can consider these as the PID. Okay. And these as the PPID. Okay. PID is the process ID. PPID is the parent process ID. Now here the process which is running with the process ID 3000, which is having a parent, as 2888. So actually this is having, it means that it is having a dependency on this process. Okay, this is having a dependency on this process. Now this is pointing to here. The same case here. Now this 2888 is having a dependency on 1556 process number. Okay. Oh, sorry. 1 minute. I didn't record it. Okay. So like that, each and every process here they are having the dependency. So 1200 is also here, and which is having a dependency of 8850, 870, and 870 is having a dependency on the process number 1, and the process number 1 is indicated here, and the process number 1 is having the PPID as 0. So it means that all the process is running under a dependency. Now say for an example, if I kill this 3000 alone, okay, if I'm killing this process using a command called kill 3000, now what will happen? Ramesh, can you tell me what will happen if I use this command? The only one process
the
will
only
get,
dependent
yeah, only
the one
one
process
process
will
will
get
get
killed.
ended. Now what will happen if I use
Yeah.
this kill space 1? If I kill this,
So everything will be
so
killed.
everything will be got terminated.
Killed.
Okay, so it means
Yeah.
that here we are having a dependency for each and every process. So that is to understand the PID and the PPID. Here there will be another type of process will be there, that is called as a zombie. So what is the zombie process? Now say for an example, so there will be some process which will be keep running on the concurrent basis, okay, which will be keep on running. Say for an example, you take the Java process, okay. So even if we try to kill, okay, even if we try to kill, use due to this concurrent process which will be keep on running. Now say for an example, I have a Java process which is running with an ID of something 2500, which is having the parent ID as 2000. Okay. Now I am killing this. Okay, I am killing this 2500. Now what will happen is this process will get terminated. Okay, this process will be get terminated, but again it will be available in the PS table. It will be available in the PS table, and it will be not thrown at the from the PS table. So till this time this process, okay, this process is called as the zombie process, because since it is having the dependency from the 2000, okay, this the same process can be activated again by the parent process. So that is zombies, we can take the general example of the zombie, uh, which is currently not live, but it may get activated at any time. Okay, which may get activated at any time. So that is the zombie process here. The
Okay.
another tab here you can able to see the zombie process, which derives from the common definition of zombie, that is the undead person. Okay. So while killing it, it will get terminated, but which will be available in the PS table, which may be activated again by the parent process. So those are called as the zombie process here. So there are many command to list the number of process which is available in the Unix machine. So you can use this E also, where it will be bringing all the processes. Okay, you can use U, okay, where it will be printing only the user. Okay, so the current user is the current user is the root. So it will be printing only the process which is running under the name of root user. Now say for an example, if you would like to use ps-u root also, you can able to use. So here it will be showing only the process which is running under the name of root user. So, okay, see here, now I'm just logging in with another user, that is user 2. I hope this user exists. Okay, see here, now I have logged in with user 2 here. I'm just creating one process and a long running process here. Okay, now here I'm just making it ps-u user 2. See here, now it is showing what are the process which is running under the name of the user 2. Now here it is showing the 3768 PID, okay, where the TTY is unknown. The terminal ID is unknown because SSH. So through the SSH protocol, this user has been connected. Through the SSH protocol, this user has been connected. Now see here. The next is by default he is running with the bash shell, and the third one is the cat command which he was running this process, which he was running with the PID of 3841. You can able to see the same process with the 3841. So here if you want to figure out the process which is running under a particular user, means you can use the -u option. And the next one here we have the ps-e. Okay, this EF, what it will do is, where it will be bringing all the process regardless of the user. You can able to see regardless of the user, both the system and the user process will be listed here when we are using this EF. Now if you want to find out any process, okay, now say for example, which we have studied this pipeline and the grub, I want to find out which process is running with a particular PID. Okay, say for an example 3000. Okay, so I don't have any process with the number with the PID 3000. Here this one is the one which has been listed here for the process which we have executed here. Okay, now say for an example, I am making it for 3486. So with this 3486, I am able to see one process is running, which is called as the K worker, and that is the system process. So how we can able to differentiate which is a system process or not? When you see this question mark on the terminal side, okay, when you see this question mark on the terminal column, which you can decide that is the system process, because which will be running in their default terminal. Okay, so now I'm going to tell you how to create a process. Okay, see whatever the command which we are executing, the ls command, date, calendar, okay, sorry, calendar, and when you are checking with the whoami command, so all these commands, okay, all these commands are considered as a all these commands are considered as a process, okay, but which are which are not a long running process, which are the short running process. Okay, now I am going to create a long running process. See, I am going to use these two files for creating the long running process. This one, this zero file, okay, so which is a character file, okay, which is a character file which will be used for the internal purpose, where it will be keep sending the output, okay, where it will be keep sending the output. Now the other file, null, okay, so as you know about the null, which is called as an error bucket file, which will be keep trashing the data which is coming in. So this will be sending some data, and which this will be trashing it immediately. So this process will go on in a this process will be going on in a chain. So what I'm doing here is cat space dev 0. Okay, I'm redirecting the output of 0 file to a file called null. Okay, so now if we start this in this same fashion, so it will be running on the front end. Okay, it will be running on the front end, where we cannot able to execute any other command until this process is completed. Okay, so now what I'm doing here is I'm just interrupting this, and I am running the process in the background. Okay, how we can able to run a process in the background? By having an ampersand sign at the end of a process. By having an ampersand sign at the end of a process, we can push the process in the background. So that is 4496. Now this process is running with the PID of 4496. So like this, I am creating many background process. You can able to see here there are some 5 background jobs are running. Okay, these are the job ID, and these are their process ID 4496 4509 and all those things. Okay, now I want to monitor. Okay, I want to monitor the background running process. Only the background running process. The command which we can use is the jobs-l. Okay, now are these 5 jobs are running? The which has been created, so which is listing it. Okay, since this is the system process, we can create as many as process which we need. But while learning with the process commands, we need to choose a long running process. Okay, so that only you can able to get the status, you can kill it, and you can keep manipulating with the process again. Hmm? Okay, now as a next step, what I'm going to do here is I'm going to kill the process. Okay, as we have created it, I'm going to kill or terminate. Okay, see, before killing or terminate, if we check this command, kill space -l. Okay, so these are the signal terms which will be used for the many purposes. Now here we are going to use this signal term 9, that is this signal kill, okay, where the particular process will be killed. Here we have two signals, that is signal kill and the signal terminate. Okay, so what is the difference between the terminate and the signal kill here? Signal terminate means, so the process will be terminated gracefully. That is where it will be waiting for the other process to be killed, and then it will be killed. Where the signal kill will be doing a force kill. Okay, without having anything in the mind. Okay, without having anything in the process, where it will not consider any other process, where it will be doing the force kill. That is the difference between the signal kill and the signal term. If you want to use both, we can use. See, now you could be able to see the difference. Kill -9, okay, and I am using the number as 409. Okay, I am killing the process 2. Okay, I am killing the process to kill -9 4509. Okay, so what it says, the process has been killed, the second process which was running with the PID 4509. Now you could able to monitor the same process again. So do we have the process which is with the PID 4509?
No.
Yeah. So now you can able to see the process is killed. Now here I'm using kill command without any signal term. Okay, kill 4496. So now it says it's got terminated. Okay, so now when we are not using any signal number here, by default it will be taking the signal term 15. By default it will be taking the signal term the 15. So that is the difference between killing a process and the terminating a process. Now you could able to see those first process will also be not there, which we have killed by using the PID 4496. 4496 is not there. Now you can able to kill even more than one process at a time. Kill -9, say for example 4511, 4513, 4515. Now you can able to see all the three processes has been killed. So check out the background jobs list. So now I don't have any jobs running in the background. So we have killed everything. Okay. Now the other commands which we use. Okay, if you see the chart here. Okay. 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 There is an option also called where we can able to stop the process. That is hold the process. Okay. Now say for an example, I am creating one more process here. Okay. So you can able to see jobs -L. So one background process is running. So what I'm going to do here is I'm going to stop the process. So kill -stop. It should be in the uppercase. Oh, now, okay. Okay. Kill -stop 5332. Okay. You can able to see the process has been stopped. You can also check with the command once again. See here. Now I have given a signal, okay, for stopping it. I have given a signal for stopping it. Okay. So now I would like to continue. Okay. I need to unhold. I need to unhold the process. So here you can use the command, the cont and the process ID. So what is the process ID which is running with 5332? Now we can able to check again with the jobs-L command, that is the process is running here. So by this way, you can able to hold the process and you can resume the process by using this continue command. Now we have the other types of process which is called as the foreground and the background. Okay, what is this foreground and the background process? See here, when you are running a command as usual. So this ls command is the foreground, I can see now, and this date command I'm running in the foreground, and this calendar command I'm running in the foreground. Okay, so when you are running in a command in the background means you will be using this ampersand symbol. Okay, when you are using this ampersand symbol, it means that the program is running in the background. Mhm. Okay. So now it says the process is running in the background. Okay. Ramesh, 1 minute, I will be back.
Okay.
So we can able to run this process in the foreground or in the background, and again we can able to check the same process again using this job hyphen the L command. Now, so even we have seen the killing a process with the PID. Okay, so there is a command. So we have seen this command kill hyphen n 5332. Okay, killing a process with the PID. Even we can able to kill the process with the process name. Okay, with the process name means, now say for an example, I am creating again this cat process again. I am trying to kill with the process name as cat. Okay, but again if we are having like many other commands starting with a cat, okay, so this file may be get deferred by any way. Okay, but at the time we cannot use this cat and we cannot do the pkill, because all the process which is running with starting with the command cat, everything will be killed. So it's better to always go with the PID. Okay, so killing a process with the PID is an something as a standard one in the real time. Okay, now a process running in the background. Okay, I have these two processes which is running in the background. Now I want to bring this process from the background to the foreground. Okay, I want to bring this process from the background to the foreground. So now these are the 5686 5688. So these two processes are running in the background. So I can say the BG, FG, which is running 5686 and 5688. Okay, now what I'm going to do here is I'm going to bring this background process to the foreground. So how I can able to bring this background process to the foreground? By using a command, if you use an FG, okay, FG percentage 1. Here the 1 indicates for the job ID. Okay, that is 5686 I am going to bring FG percentage 1. So you can able to see here now it is started running in the foreground. Okay, now if I use Control C, where the process will get terminated, and I can able to see only one process running, which is with the PID 5688. So the one process which was running in the background, that is 5686, where we have brought it to the foreground, and then we killed it. Okay, so this is how we will be bringing the foreground process to the background process. And here next command which we have is the no-hub. So what is this no-hub? Okay, no-hub means the no hang up. Now say for an example, our server will be somewhere in the remote place, say for an example US. Okay, by using the IP address. Okay, like how we are connecting with the putty. Okay, just by using the IP address we will be connecting it from the machine. So the IP address will be the same, 192.168.1.2, something like that. So here I am accessing the same server from Chennai, and here I am accessing from the Bangalore. Now say for an example, if I am and one backup script is running, okay, one backup script is running, okay, this mission is going for shutdown. Okay, this mission is going for the shutdown. Now what will happen to this process? This backup.sh?
It will be killed.
So it will be terminated. Okay, to killed or the terminated. Okay, but when I want to run this long running process, okay, say for an example, this is running for the 24 hours. Okay, what I can do is using this nohub command. Okay, using this nohub command, I can make this particular process directly running on the server. So even if it goes for the shutdown, the process will be running in the background in the server and not on your terminal. Okay, and not on your terminal. For this case, we will be using this nohub command. Okay, now see here, let me create a job. Nohub. Okay, this nohub command will be automatically delivering an log file. Okay, so something like a nohub, say /etc/password, and I'm using the ampersand symbol. So here now it says the process has been started with the PID as 5849, okay, and it is being done. Okay, that is the process has been completed by throwing the output to a file called nohub.out. If you would like to verify, you can able to verify the same. Here we have a file called nohub.out, so which has been generated now. You can check the content also, cat space nohub.out. That is the command cat etc password. Now say for an example, I am creating another process. Now say for an example, I am just trying to execute one command, that is uptime. Okay. Now check the content of this nohub file, cat space nohub.out. So you can able to see the next output. So this is by default. If you want to change, okay, if you want to change the output into the different files also, you can able to do that. So that is the use of a nohub command. So where it will be running directly by attaching to the server and not to the terminal. Okay. Right. So here the next thing which we have here is the, so here I have given the same explanation what we have studied in the examples. Okay, the next one here we are going into the a command called top. Okay, so this top command will be giving some 90%, okay, from 90% of a system details. Okay, it will be giving most of the details about the system. So I'm going to explain all the factors here in this command. Okay, so you can listen carefully. The first one, okay, in the first line, see, you can able to see the readings will be keep changing because it will be updating the latest value for every 3 seconds. Okay, it will be updating the latest values of the server for every 3 seconds. Now here the top command, okay, the top command now says the first line, it will be first is the time, the server time. So now it's 8:47. Okay, now it's 8:47, up 44 minutes. What is this 44 minutes? It means the server is running without the reboot. The server is running without the reboot of 44 minutes. You can able to get this first line also from the another command called uptime. See here. So people will be asking how many for how many minutes or the hours the server has been running. So I can say for the 44 minutes. Okay, the server is running without the reboot for the last 44 minutes. Okay, now in the top command. Okay, in the top command, now I can say there are 3 users are currently connected. There are 3 connections to the server. How many users are currently online. Here I can verify it by using the who command. See here. You can able to see there are 3 users has been connected to the servers. One here that is directly in the server, okay, through the putty. Through the putty, this 1.1 is our gateway. Hope you remember this, Ramesh. Okay, so these 2 users has been connected through the Windows machine. So totally 3 users are connected. And the next one, the load average for the last 5 minutes, 10 minutes and the 15 minutes. So what is the load average for the last 5, 10 and the 15 minutes? Okay, tasks. Okay, so what is the task here? Now, here the task, here it will tell how many total processes are currently available. Okay, how many processes are totally currently available? So that is 333 processes are currently available. And here how many processes are running? So that is 3 processes are running here. Okay, and 330 processes are sleeping. Sleeping means which is inactive, but it may become active at any time, or user can activate those processes. Okay, that is the sleeping here, which is currently available and not yet activated. Okay, and here the how many system process has been stopped. Okay, we haven't stopped any system process. And how many zombie process are there? Okay, I have told you what is the zombie process is all about, and here we don't have any zombie process. And the next one, the CPU. The first 4 are important. The first 4 readings here always in this third row, the first 4 are important. That is, in the CPU I can able to see the 1.7. 1.7 CPU is utilized for the user process, and 98.3 is used by the system. Okay, and 98.3 is used by the system process. And here there is a 0% of the CPU which is used by the nice value. Here the nice value means nice value is used to prioritize the process. Here you can able to see something as a priority number here. Priority and a nice value. So these two, priority and the nice value, defines the CPU for this nice. Okay. So now how much of CPU, okay, how much of CPU is ideal? Okay. So 0, because the 98 is occupied by the system and again the 2 is occupied by the user process. So there is no free CPU utilization. There is no CPU utilization. Okay. Now, so what is the process which is occupied by the waiting process? Okay. The CPU occupied by the waiting process is 0, and by the hardware resources. Hardware is something like the RAM, motherboard, processor, PROM, CROM. Okay. So CPU utilized by the those hardware process, and this is for the software. Okay, the CPU utilized by the software which is currently running, and the last one is the providing the statistics. Statistics means, so even now this top command is providing some statistics, right? So statistics means like again giving a report. So even for generating this report we need some of the CPU. So that is the ST. Okay, now coming on to the memory part. Okay, so which is showing in terms of the KB. So this is the first one is the physical memory and second one is the swap memory. Okay, in general, what is the difference between the physical memory and the swap memory? Any idea, Ramesh? What is the swap memory?
No, I don't have any.
Okay. Okay, so here the physical memory. Okay, we can consider this physical memory as a RAM. Okay, here the RAM is the physical memory. You would have able to see in the RAM something like this. okay, which we will be using in our machines. Okay, now this is considered as the physical memory. Okay, and here the swap will be created within the hard disk. The swap will be created within the hard disk as one partition. Now say for an example, I'm using this as a swap. Okay, both of this memory which is used to process the data between the hard disk and the processor, where we'll be having a processor and the hard disk. So the data which is read by the hard disk is done by the RAM, okay, and then it will be given to the processor. So that is the use of a physical RAM here, okay. Or even I can able to what is that, draw this process here. That will be, I think, appropriate. Okay, here, okay, here we have the processor. Okay, here we have the processor. Okay, and the data, the usage of RAM is here is to communicate between the processor and the hard disk, and which will be done the vice versa. Now, say for an example, when this physical memory, say for an example, I have the 2 GB of physical memory. If this 2 GB is being filled, okay, if this 2 GB is being filled with the size, okay, that is 2 GB. Now the next step what it will take is it will get into the using a swap size only if it is full, only when the RAM is full. Okay, only when the RAM is full, then we can able to take, okay, then we can able to take the swap partition size. Now see here, we have approximately something 1.8 GB in the physical memory. Okay, 1.8 GB. Now it has given in terms of RAM. If you convert this into MB, it will be 1878 MB. If we convert it into GB, it will be something like 1.8 GB. Okay, that is the memory calculation. Now, out of this 1.8 memory, how much is used? How much is used? That is 662 MB. 662 MB is used. Okay, and then how much is free? Okay, how much is free memory? That is 1000. We cannot say as an 1000. We can say 1.2 GB is free. So this is the 1215 MB is free and 1.2 GB is free, and this is the number in the buffer. Now, since you can able to see some of the numbers in the physical memory itself, and hence the swap sizes is not used yet, and hence the swap size is not used yet. So that is the plan here. So when you have a 0 in this physical memory, then it will be start occupying the swap memory. Okay, when you don't have anything in the physical memory, it means that when the physical memory is fully occupied, then it will be utilizing the swap memory. Okay,
Here, do we need to install the swap memory, or
it's not installing the swap memory. During the installation, by default, it will be considering one partition. See here, during the installation, we will be creating something like a for slash. It's 20 GB. Okay, and there will be an one partition called slash swap. Okay, which will be occupying the 4 GB. So during the installation itself, we will be giving this partition, which will be occupying the space in the our hard disk, that is HDD.
okay.
So during the installation itself, we
What
will
about
be giving it this. Yeah.
what about if we wanna give more swap memory
Okay.
right now?
Okay. If you want to increase the swap memory means, then you would have created the partition using the LVM concept. So we have something called as a logical volume manager, where you can increase the size or you can decrease the size using this LVM technology. Yeah.
There's a third party, or it should be done in command mode?
Yeah, everything in the command mode. So we can increase the size or we can reduce the size using in the command mode itself. For example, the LVM, we have something like LV extend plus 200 M, okay, and for this partition. So what it will do is, it will add an 200 MB for this partition. This LV extend will be extending this partition by having 200 MB again. You can make it as 200 MB or 200 GB,
Got it.
whatever it is. Okay. So that is how with the memory here. And the next one here we have the columns here, the particular process ID, okay, the unique ID for each process under which username it is running, whether root or GDM or Ramesh or Santosh or Arun, it will be showing the respective username. And here you can able to see GDM, Polk ITD. So these are the different users running the different process. And here the priority. So by default you can able to see the priority number as 0 for everything here. And for some of the process you can able to
0
see,
for highest level.
yeah. And here you can able to see some process, something called as the RT. Okay, what is this RT? See, RT is the real-time process where you cannot change the priority. See, again in the real time we will be changing the priority only for the user created process, and we will not changing the priority for the system process. Again, even if you change the system process, the priority, and it will be not also the great effect. It will not have an impact. Now,
Okay.
consider this scenario. I have one Unix server. Okay, so in that Unix server, I am hosting 3 applications: IRCTC, Facebook, and Flipkart. Okay, these 3 applications are running. So the peak hour for IRCTC is, I can say, 10 to 12 a.m. Okay, and the FB peak hours is, I can say, 6 p.m. or after 9 p.m. will be the peak. Okay, and Flipkart will be, it will be normal by all the 24 hours. Okay, so now when all these 3 application is running on a single server, so I need to give and more importance to the IRCTC during the between 10 to 12 a.m. I need to give more importance to the FB at the time of 6 p.m. or after 9 p.m. Okay, and the Flipkart will be the traffic. The traffic to the Flipkart will be nominal around the 24 hours. Okay, so I don't want to set any priority. Now I need to set the priority for the IRCTC, okay, at the 10 and 12. Okay, here the priority value is inversely proportional to the nice value. Okay, the lesser the priority, the higher the priority value, and lesser the priority value, and here the
Lesser important.
lesser the, now for example I can say 10. Now if I make, now if I want to priority as 1 here, then I need to go for the minus 19, something like that. So lesser the priority value, lesser the nice value, greater the priority value. Okay, Now say for an example, if I'm making the nice value as minus 17, then the priority value will be 3. Okay, if you want the priority value as 1, then you need to make the nice value as minus 19. The nice value here ranges from minus 19 to plus 19. Okay, this is the value range in the nice. Now let's see how we can able to prioritize. Okay, that is using this nice value, how we can able to prioritize the process. Now say for an example, here we have the two commands, something called as nice and the renice. So both of these processes used to prioritize it. Okay, the nice command we will be using, to create a new process. Okay, the nice value which we are using here to create the new process. Here the new process means I can able to create a process with a nice value. Now say for an example, I'm just creating it. Nice, okay, this is user, okay, here. Nice, say for an example, iPhone 15, okay. Here this iPhone 15 and that should be, if you give a minus, then you need to have another hyphen here. That is iPhone minus 15. I am creating a process which will be running with the priority iPhone minus 15. I just creating in the background, okay, which is running with the 7611. You can able to monitor the same in the top command. The PID which we have created 7611 is running with a priority as 5 and the nice value is minus 15, which we have assigned it. Okay, now I am going to change the priority. See here, the nice command is used to set the priority value for the new running process, that is for the new process. And here we have the renice command. Okay, we have the renice command to change the priority value for the process which is already running. Okay, change, okay, change priority value for process for already running process, we can say like this. Okay, change priority value for already running process. For that case, here we use this renice command. Now the process which is already running with the priority 5, I want to make the 5 to 1. Okay, so I am renicing it, renice, okay, minus, so what is the value which you want? Okay, say for an example 19. Okay, and for which process -p, the process ID 7611. So for this process I would like to, okay, I would like to change the priority value. Now here you can able to see the for this process 7611, the old priority value was minus 15 and the new priority value is minus 19. The old priority value is minus 15 and the new priority value is minus 19. Now you could able to see the same top command. See here. Now this process which is with the 7611 is having the priority value as 1 and where its nice value is minus 19. Okay. So here you can able to see the rest of the columns which are the different the memories, and here you can able to see the status yes. R and S, some of the processes which is running R and some of the processes which is sleeping. And here you can able to see the each process, okay, the process which is occupying the CPU by the each and every process. Now this cat command is occupying the CPU as 92.9 and what is the physical memory which is being used. Okay, what is the physical memory which is being used to pull it, okay, or to run it, we can say. So the process wise we can able to see what is the CPU utilized by the particular process and what is the memory utilized by the particular process. Okay, so that is here with the top command. Here using this nice value, okay, using this nice command, even we can able to change the priority value for all the user process. Now say for an example, I have a user called Java. Okay, I want to change all the process which is running under the Java name to some value. Okay, so I cannot, if it's having some under processes is running, I cannot keep including all the under PID here. Okay, so hence what I'm doing here is priority, say for an example, hyphen minus 18 hyphen u root. Now what it will do is instead of having a PID, here I'm having the username. Now all the process which is running under the name of root will be having the nice value as minus 18. You can able to see now. See here, all the process which was running with the username as root, which got changed to the nice value as minus 18, and the priority became as a 2 here. So this is how we will be prioritizing the process.
So here, what about the fifth column, sixth column, and seventh column? What is that exactly means?
Okay. See here again in the real time, this one, this virtual memory, residential memory, and the shared memory, we will be not having much eye on this three memory, and also again
Okay,
which will not affect the an application. By using this, we will not considering the real time application these statuses.
okay,
Yeah, and again which is being used for the code purposes.
okay.
Right. Okay. So I'm done for today.
Okay. Here,